Hi, I'm Haman, the team leader and lead machine learning developer.
Hello, I'm Emily Yuan, lead data analyst in this project.
Hi, I'm Boris, the metrics and visualizations lead for business intelligence.
Hello, I'm Josh Brown, business consultation and marketing lead on literacy. Barcelona is one of the world's most challenging settings for companies such as Uber and Lyft. This is due to its world-renowned public transport history of conflict between taxi drivers and ride-offering companies, and its culture based on cycling and walking. This greatly hinders the development of ride-offering companies like Uber.
Considering all these challenges that Uber faces in Barcelona, we decided on the question, how can Uber grow revenue and market share while building a positive brand image and comply with governmental policies?
In our analysis, we were able to identify and separate both qualitative and quantitative the city of Barcelona. And among the rich conditions and environment of the city, identify hidden opportunities with solid business recommendations through traditional statistics to advanced algorithms and research. Our first step was to secure our data. Outlier coordinate range that were caused and solved by a common misplace, and a total of 3,081 missing values in 4 datasets. Handling missing values is a crucial step before applying any machine learning algorithms. In the first dataset, missing values were filled by similar available mean data. The strategy for missing numerical variables in ordered timelines was applying backward fill, an advanced technique that lets us fill the missing values with the next available number in index order. Applying machine learning to prevent biases. Air quality level variables were discovered to be a summary of how bad or good HR metric is. For its missing values, a machine learning model was trained to understand, based on the available non-missing data, how these professional evaluations were concluded in order to fill and predict the quality levels for the missing rows. We cannot ensure a quality analysis of Barcelona without complete transport information. Next two datasets, I obtained district and neighborhood names based on the coordinates given to GeoPy Python library. In our second step, I separated our given data into the following sections: demographic statistics by neighborhood, citizen safety, which involves accidents and air pollution rates, public transport availability, and even using external sources, a continuous practice in real-life projects, hotel, taxi, and office statistics per neighborhood. Combining all datasets and maintaining the corresponding industry standards, such as applying PCA to improve our clustering results, I was able to apply an algorithm that groups Barcelona's 73 neighborhoods into 4 groups, named correspondingly Cluster 1, 2, 3, and 4. Being able to truly profile our target audience was key to the following supplementary analysis and business outline.
Moreover, we took steps to augment the dataset by extracting valuable insights, such as calculating the distance to the city center and financial districts. Additionally, we combined different datasets which were outsourced by our team, further enhancing the breadth and depth of our data resources. This process bolstered the quality and reliability of our dataset. After this step, we did some exploratory analysis to discover basic trends in our data, such as public transportation coverage, which portrayed the trend of increasing coverage as proximity to the city center increases. We also looked at key metrics such as the population of neighborhoods.
I initially experimented with a statistical model to calculate price changes based on predefined scales extracted from clustering results. However, I realized that as data dimensions increased, this approach became less feasible and limited possible input conditions. I thought of solutions and decided to shift to fuzzy logic, a technique that handles imprecise data using degrees of truth for nuanced decision-making. Uber Dispatcher is a dynamic fuzzy logic-based inference system capable of synthesizing and analyzing numerous data dimensions to determine neighborhood-specific price adjustments, considering many factors deemed most relevant in early stages of exploratory data analysis. It optimizes market share and brand image by accounting for various factors, such as seniors' presence, pollution levels, accident rates, number of public transport stations nearby, number of immigrants, number of hotels, and others. The weight of the input factors were determined through initial data analysis and the usage of business metrics. Using a fuzzy system to achieve this allows us to consider all factors using human-like reasoning, creating a robust model capable of tolerating a much greater range of conditions compared to using a traditional approach, while also removing the need to idealize the data or reduce complexity. Now that we know what Uber Dispatcher is, here's a simplified breakdown of its development process. First, we categorized factors as positive and negative, and scaled them using min-max scaling. Then, I used the elbow method to determine the optimal number of clusters or categories for each feature. Once that was done, I defined custom membership functions and rules for each feature to accommodate data distributions and outliers, then created a control system and simulation environment. And finally, I ran the code to calculate the ideal negative and positive percentage change for each neighborhood, resulting in a net percentage change. The power of this system stems from its scalability, feasibility, and effectiveness. The fuzzy model is capable of taking in hundreds of features as input and calculating the ideal percentage change in real time. Not to mention that later down the line, it can be fed live data from satellites, environment stations, and local authorities to improve on its capabilities. This system will revolutionize the way Uber functions. Targeted marketing is now rerouted to direct discounts to those who are suited for them the most. Areas with no dependence on Uber, higher risk, or more pollution will receive an increase in price the most. A better brand image is established, governmental policies are better complied by, and Uber drivers in certain areas are also being further incentivized by higher paying customers, all while losing less than 0.89% of revenue on average.
Cluster 4 neighborhoods have the lowest public transit coverage on average and are generally the furthest away from the center of the city. Uber can address transportation needs of residents in these areas by increasing the number of drivers here, especially at night, when public transit options become even more limited. Clusters 1 and 3 are more affluent regions, with strong public transportation and high competition from taxi drivers. These regions are more competitive, and it would be inefficient for Uber to station a large number of drivers in these areas all the time. Instead, Uber should focus promotion towards Uber Eats, a service which tends to be more popular in wealthier regions. Furthermore, Cluster 1 neighborhoods are on average 2 kilometers from central Barcelona and have an average of 5.5 hotels per neighborhood, which is significantly larger than the average number of hotels per neighborhood in other clusters, which is 1. To target Cluster 1's higher number of hotels, Uber should establish partnerships with leading brands like Catalonia Hotels and Resorts to have designated Uber waiting areas and promotional signs in lobby and concierge areas. Cluster 2, with its moderate air quality and higher number of accidents, suggests potential for Uber to promote its services as a cleaner and safer alternative to traditional modes of transportation. This can be done through environmental sustainability campaigns. Barcelona continues to struggle to meet its goals to improve air quality and reduce carbon emissions, so our main initiative will be the BioChoice Rewards program, aimed to promote Uber Green and Uber Pool rides. Riders will earn credits for their next BioChoice ride based on the distance traveled with Uber Green or Uber Pool. For every kilometer traveled, riders will earn BioChoice points. 1 kilometer earned earns 1 BioChoice point. And these points can be exchanged for BioChoice specific rides, that is, on Uber Green or Uber Pool, and 20 points can be exchanged for a 1 kilometer ride. This strategy will offset revenue losses from rewards with increased customer loyalty and a revenue increase, resulting from targeted customer demand for sustainable rides. This BioChoice Rewards program reflects Uber's understanding of Barcelona residents' values and aligns with government policy goals for sustainability once again.